In this video, we will begin to look at partial sums and sigma notation. So partial sums and sigma notation is a relevant and natural extension of sequences. So in this video, we'll look at partial sums, sigma notation, and partial sums in sigma notation. So we'll begin with the definition. For the sequence A1, A2, A3, all the way up to AN, the partial sums are S sub 1 equals A1, so the first partial sum is just A1. The second partial sum is A1 plus A2. The third, A1 plus A2 plus A3, all the way up to the nth partial sum, which will be A1 plus A2 plus A3, all the way up to adding AN. So again, S1 is the first partial sum, S2 is the second partial sum, S3 is the third, and S sub n is the nth partial sum. So let's look at a quick example. Find the third partial sum of A sub n equals 3n plus 1. Okay, so the third partial sum, S sub 3, equals A1 plus A2 plus A3. So we're just adding the first three terms of the sequence A sub n. So first let's find A sub 1. So that's 3 times 1, where n is 1, plus 1 equals 3 plus 1 equals 4. A sub 2 equals 3 times 2 plus 1, which will be 6 plus 1 equals 7. And A sub 3 will be 3 times 3 plus 1, which will be 9 plus 1 equals 10. Okay, so now plugging A1, A2, and A3 into S3, we have S3 equals 4 plus 7 plus 10, which altogether gives us 21. So 21 is the third partial sum of AN equals 3n plus 1. Now, in some situations, writing the 100th partial sum will get pretty tiring pretty quickly. So let's look at the brief way to write a partial sum. So consider if we have, if we're looking at the fifth partial sum, that's A1 plus A2 plus A3 plus A4 plus A5. We can write this very briefly using what's called sigma notation. So sigma notation uses the Greek capital S, sigma, and we have a summation index, k equals 1, and we sum to some other number, 5 in this case, of the sequence A sub n. So this just tells us k equals 1 tells us where we start. The number on top tells us where we end. The sigma tells us that we're summing. And A sub n is just the sequence over which we're summing. So altogether, this would look like A1 plus A2 plus ... plus A5, as we just saw in the fifth partial sum. So writing the 100th partial sum, we would do this as, do this in a different color. We start at k equals 1, sum to 100, and over the sequence A sub n. So this here is the 100th partial sum, and we could call this S sub 100. So quickly, two definitions. We can briefly write a sum of any number of terms as the sum from k equals 1 to n of A sub k equals A1 plus A2 plus A3 plus all the way up to plus AN, where sigma is the Greek capital S for a sum. K is the index of summation. K equals 1 tells us where to start, and k equals n tells us where to end. The left-hand side in this case reads the sum of AK from k equals 1 to k equals n. This is called sigma notation. We can also write any partial sum S1 through Sn using sigma notation. It's much more convenient and it's much shorter to write a partial sum in this way. So for the sequence A1, A2, A3, all the way up to AN and beyond, the partial sums are defined in sigma notation as S1 equals the sum of AK from K equals 1 to 1 equals A1. So this is just to say that we're summing from the first term to the first term, and we'll only have the first term. And of course, as we just said, for any nth partial sum, we sum over the sequence AK, starting at K equals 1, ending at N, and that would give us the nth partial sum. So consider the sum 2 plus 4 plus 6 plus 8 plus 10. So we have 5 terms, A1, A2, A3, A4, and A5. So since this is a sum, we need to write our sigma. We start at the index K equals 1, and we end at the term 5, right? We have 5 terms here beginning at A1. Now we need to write the name of this sequence so we can put that inside the sum. Fortunately, this is a pretty easy sequence to identify. This is just 2 times the index. So this will be 2K in this case. So we have the sum of 2K from K equals 1 to 5. We'll do a quick partial sum as well before we wrap up. So this is the 6th partial sum, because we start at A1 and we end at A6. So writing that, again, we need a sigma because this is a sum. We'll start at the index K equals 1, we'll end at the 6th term, and because this is just a general sequence, we can write AK, and that will give us the 6th partial sum. In the next video, we'll look at a couple properties of sums